All right, welcome back to Calculus with Mr. Robeson. So this is the last one for 2.4, the chain rules. We're going to look at the chain rules some more, do some more examples and applications like tangent lines, and then we're going to combine some derivative rules. These do get a little rough, a little bit of work involved with some of these combinations. All right, so find all points on the graph of f of x equals this guy for which f prime of x equals 0, and those where f prime of x does not exist. All right, so one way we could find them would be to graph it, but if we don't have a graphing utility, we need to find the derivative. So we're going to write f of x as x squared minus 1, so it's to the 2/3. All right, the 2 is the exponent, the 3 is the root, so to the 2/3. So then our derivative is going to be f prime. We're doing a chain rule, so we bring down the 2/3. We've got x squared minus 1 to the 1 less exponent, so that's going to be negative 1/3. And then times the derivative of the inside, since it's a chain rule, so times 2x. And now we're just cleaning that up. So we've got a 2 and a 2x on top, so that's going to be a 4x. We've got a 3 on the bottom, and this guy has a negative exponent, so he's going to move down to the bottom. He's to the 1/3, so that is the third root of x squared minus 1. All right, now we want to find where the derivative equals 0. Well, that's where the top equals 0. So let's go ahead and change some colors here. So the top equals 0 is when x equals 0. So that means f prime of 0 will be 0. Where the bottom equals 0, that is when x equals, when this guy equals 0. So plus or minus 1. So f prime of plus or minus 1 does not exist. Looks like that would be a vertical asymptote on the derivative. All right, so there we found those. So we have a horizontal tangent at 0. So that means we have something in the graph that will be flat at 0. And something weird's happening at plus and minus 1. Let's take a look at the graph. All right, so in black is the graph. So right here is 0. So at 0, 0, we've got our slope equal to 0 right here. It looks like a maximum there. And here we have a corner and another corner. So here f prime does not exist. And here f prime does not exist. And if you look, here's the derivative in gray. And if you notice, there are vertical asymptotes right at these dotted lines at 1 and negative 1. And right here, the derivative equals 0. And to keep you interested, here's a picture of Max at doggy daycare with 2 friends. I know, he's adorable. All right, next one. So now we are combining derivative rules. So we have something with x times something else with x. So that looks like we should be doing a product rule. All right? But this guy is 1 minus x squared raised to the 1/2. So for that guy, we would have to do a chain rule when we do the derivative of this one. So we're doing a product rule, and inside of the product rule, so product rule with a chain rule. Like I said, everything's a chain rule, guys. All right, so f prime then will be, well, the product rule says it's first, so just x squared, times the derivative of the second. So we're going to do a chain rule here. We bring down the 1/2. We leave the inside the same. Subtract 1, we get negative 1/2. Times the derivative of the inside. 1 is 0. We have a negative x squared, so that's going to give us a negative 2x. All right, so that's just the first guy. So that's the first times the derivative of the second. Plus the second, this part's going to be a little easier, 1 minus x squared to the 1/2 times the derivative of the first, which is just 2x. Voila, there's our derivative. Unfortunately, if this is multiple choice on the AP exam, it will not look anything like this in our answer choices. They'll do some sort of simplifying. So let's try and simplify each term here first. So we've got an x squared, a 1/2, a negative 2x. So the negative 2 and the 1/2 are going to cancel out. So we're going to have a negative x and x squared. So negative x to the third. And this guy's to the negative exponent. So we're going to bring him down to the bottom and say that's the square root of 1 minus x squared. Our other guy, we've got 2x times the square root of 1 minus x squared, like that. And they may leave it like that on the AP exam. It might look like that on the AP exam. All right, or they could get a common denominator. So if we get a common denominator here, this guy needs to have a square root of 1 minus x squared. And anything we do to the bottom, we also have to do to the top. All right, so this guy is now going to be 2x times these here. The square roots are going to cancel out. We're just going to 1 minus x squared over the square root of 1 minus x squared. Still plus this other guy. So negative x to the third over square root of 1 minus x squared. So now we have a common denominator, so we can put those tops together. We get negative x to the third plus, if we distribute this 2, we're going to get negative 2x to the third plus 2x all over our common denominator of 1 minus x squared. And we can combine like terms here. We're going to get negative 3x cubed plus 2x over the square root of 1 minus x squared. We'll probably leave it like that. If they asked us to set it equal to 0 or find horizontal tangents, then we'd probably want to factor out an x from the top and set it equal to 0 and try and solve that, which we could solve. All right, but that's it for now, for that one. Next up, oh boy. So we have something with x divided by something else with x. We can't really simplify this any. So that means we are going to do a quotient rule. All right, but when we do the derivative of the bottom, we're going to have to do a chain rule. So we're going to do a quotient rule with a chain rule. So the first thing I'm going to do is I'm going to rewrite this bottom. Before we take any derivatives, I don't like having roots. I'm going to write this as to the 1/3. All right, so now let's calculate our derivative. So remember the quotient rule says low d high minus high d low, square the bottom, and away we go. So we start off with low, x squared plus 4 to the 1/3 times the root of the top, times 1, minus the top times the root of the bottom. So this one we have to do a chain rule. We bring down the 1/3, leave the inside the same, to the 1 less exponent. So now it's going to be to the negative 2/3 times the root of the inside, and there's the top, all over the bottom squared. So we're going to have x squared plus 4. If we square 1/3, that means 2 times 1/3, not 1/3 squared. We get 2/3, like that. Simplifying this is where it gets really tricky. All right, so if you look, both of these guys on top have this x squared plus 4 to some exponent. That means we could factor out that x squared plus 4. And when we factor out stuff, we factor out the one with the smaller exponent. So if we factor out the x squared plus 4 to the negative 2/3, what happens here is, well, we're dividing by it. So 1/3, and it's going to be over this to the negative 2/3. So we're going to get 1/3 minus negative 2/3. So that's 1/3 plus 2/3, which gives us to the first. That happens almost every time. So we'll have 1/3 divided by this guy to the negative 2/3. So we subtract the exponents. 1/3 minus negative makes plus. We get 1 as our exponent times this 1. Then we got minus. Well, we took this whole guy out. So we've got a 1/3, a 2x, and another x. So that gives us 2/3. X times x gives us x squared. On the bottom, we've got x squared plus 4 to the 2/3. Well, this guy's got a negative exponent. He's going to move down to the bottom with that, and we're going to end up adding those two exponents together. So on top, we're getting x squared minus 2/3 x squared, so that's going to be 1/3 x squared plus 4. On the bottom, we've got x squared plus 4. We're going to have 2/3 plus another 2/3. That's going to give us to the 4/3. We're just going to leave it like that. We can't simplify here because of this 1/3 that's on the x squared. It's not times this whole thing. Otherwise, we could. But the 1/3 x squared throws everything off. There's our answer. Done. All right. I know we don't like this simplifying and this taking this out, but you know that's algebra right there, guys. That's algebra. If you're struggling with that, algebra and pre-calc, go back and yell at those teachers. We'll keep practicing. All right, and here's another one. So we're dividing inside, and we got the exponent outside. So if we're going to take the derivative of this guy, we start with the outside function, which would be a chain rule first. And then inside, when we do the derivative of the inside at the end, that's going to be a quotient rule. So we got a chain rule and then a quotient rule. So f prime of x is, well, the chain rule says we bring down the 2, We leave the 3x minus 1 over x squared plus 3 exactly the same inside to the one less exponent, so to the first. But then it's times the derivative of the inside. Now when we do the derivative of the inside, we've got a bottom and a top. So it's low d high. So x squared plus 3 times the derivative of the top, which is 3, minus high d low, 3x minus 1 times 2x, all over the bottom squared, which is x squared plus 3 quantity squared. So this was the whole times derivative of the inside, the quotient rule that was part of our chain rule. All right, now we're going to try and simplify so we can bring this top together. We've got an x plus 3 and 2 more of them here, so we can put those together. Let's just see what happens. So we've got a 2, we've got a 3x minus 1, we've got an x squared plus 3. Nothing really changes there. On top, we're going to have 3x squareds plus 9 minus 3x times 2x is 6x squareds minus negative 1 times 2x is going to be plus 2x. All over x squared plus 3 quantity squared. So this to the first. So when we're multiplying fractions, it's top times top, bottom times bottom. So we're going to do the bottom times bottom here. We're going to leave the 2. We're going to leave the 3x minus 1. We're going to try and simplify this. We got 3x squareds minus 6x squareds. So that's a negative 3x squareds. We've got a 9 and a 2x. So plus 2x plus 9. And then this is all going to be over this guy times this guy, so that's x squared plus 3 to the third. All right, we could multiply this out if we wanted to. We could try and factor this if we wanted to, but that's good enough for me right there. All right, so since you put up with 2 different rules at once, here's a picture of Max trying to make sure I don't get any work done by sleeping on my lap and on the computer. What the heck, Max? So rude, but so darn cute. All right, so some more practice with trig, because I know we struggle with trig, so we want to find the derivative of each one. So y prime here will be derivative of cosine, negative sine, leave the inside the same, times derivative of the inside, which is going to be 6x. We usually write it with the 6x in front then, so it's going to be negative 6x times the sine of 3x squared. All right, next guy. Again, I don't like roots, so we're going to rewrite this as tangent of x to the 1/2. Now we take our derivative, we bring down the 1/2. We leave the inside exactly the same. We don't touch it to the 1 less exponent times derivative of tangent. Derivative of tangent, let's see, tangent goes with secant. So tangent is secant squared. All right, and if there was something besides x in here, we'd multiply by the derivative of the inside. If you want to, you can multiply the derivative of x, which is just 1. That doesn't change anything. All right, so we're going to be left with a secant squared on top. We've got a 2 down at the bottom. We can bring down this tangent to the 1/2, and we'll have square root of tangent of x down at the bottom. And there's our answer. All right, finally, this guy. Remember, whenever we have an exponent here, we're going to rewrite it as this guy raised to that exponent when we take the derivative. So now we take the derivative, we bring down the 2, we leave the inside exactly the same. We didn't touch the inside at all here, to the 1 less exponent. Now times derivative of the inside. The derivative of sine is cosine of whatever's in there times derivative of the inside. All right, so we end up getting 2 sine of 5x times cosine of 5x times 5. Yeah, we can leave it like that, or we can, well, there's a trig rule if we want. 2 sine of theta cosine of theta equals sine of twice whatever theta is. So in this case, our theta would be 5x. And we have the 2 here out front already. So this is all going to just be sine of twice what's in here. So sine of, so we're just looking at this part right here. We still have the times 5. So times 5 is just still there. And then we get sine of double what's in here. So that would be 10x, like that. All right, if you didn't like that, that's okay, guys. You can leave it like this for me. That's fine. You're just trying to match answers on the AP exam. And here's Max sitting on the couch with his little Bobo. He has his own little wiener dog chew toy. It squeaks. Although he hasn't played with it for a while. But he also has his own cushion on the couch. All right, so I'm trying to break it up because this is a long one, so I'm showing you pictures of Max to make you still interested. So here's our function here, 2 sine of x cosine of 2x, and we want to find the equation of the tangent line at x equals pi. So we need a point and we need a slope. To find the point, we plug into f, the original function. So we want f of pi is, well, that's 2 times sine of pi plus cosine of 2 times pi, so 2 pi. Sine of pi is 0. Cosine of 2 pi is 1. So we get 2 times 0 plus 1 is just 1. So our point is pi 1. All right, to find our slope, we need a derivative. So we need to find f prime of x. So the derivative here, derivative of 2 sine is 2 cosine. Plus, derivative of cosine is negative sine. We leave the inside the same, times the derivative of the inside. All right, so that's going to give us 2 cosine of x minus 2 sine of 2x. And now we can plug in pi to get our slope. So f prime of pi is, we get 2 cosine of pi minus 2 sine of 2 pi. So we have the 2 in there, 2 times pi. Remember, sine of any integer multiple of pi is 0, so this guy's going to be 0. Cosine of pi is negative 1. It starts high and then goes down. It's negative 1 there, so we get negative 2 as our slope. So now we have a point and a slope. So we say y minus our y value equals our slope, negative 2 times x minus our x value. Done. All right, let's change colors, and we'll tackle the next one here. Green sounds good. So determine all values of x where in the interval from 0 to 2 pi, including 0, not including 2 pi, where f of x has horizontal tangents. All right, well, that means where is the derivative equal to 0? All right, so we've got the derivative already. So the derivative we found over here was 2 cosine of x minus 2 sine of 2x. We want to know where does that equal 0. All right, so we're going to use a little trick here. So sine of 2x, sine of 2 theta is 2 sine of theta cosine of theta. We talked about it on the last slide a little bit. So I'm going to take this part, I'm going to rewrite this so we don't have this 2x anymore. So we're going to get 2 cosine of x stays the same, minus 2 times 2 sine of theta, oh, we don't have theta, we have x, sine of x cosine of x. All right, so now we've got all x's as what's inside our trig functions. So what we do is we can factor out a 2 from each guy and a cosine from each guy. So we got 2 cosine that factors out. So this guy factored out completely, so we're left with 1 minus, we still have one of the 2's here, and we still have a sine of x. So we set each part equal to 0, so we get 2 cosine of x equals 0. So that's just when cosine of x equals 0, which, remember the graph of cosine, starts high, goes down, goes back up. It's here and here. So that's pi over 2 and 3 pi over 2. Now with the other one, we got 1 minus 2 sine of x equal to 0. So we can subtract the 1, divide by negative 2. We get sine equals 1/2. All right, so sine is positive in the first quadrant. Remember, all students take calculus, and it's also positive in the second quadrant. All right, so we get 1, 2, 1, 2, because sine is opposite over hypotenuse. The other side for both of these is square root of 3. So that means this is pi over 6, or 30 degrees. This is also pi over 6, but if we go all the way to here, that's 5 pi over 6. So we get 2 answers, pi over 6 and 5 pi over 6. So we get 2 answers from the sine, 2 answers from the cosine. So we have 4 different places where we have horizontal tangents between 0 and 2 pi. Ooh, that was rough. Fun though. All right, so that was the chain rule, and we looked at some applications. We looked at combining chain rules and product rules and chain rules and quotient rules, and we looked at doing one first and then the other first, and then we looked at some applications with finding equations of tangent lines and horizontal tangents. So that is it for 2.4. Check on Google Classroom. There is a homework assignment that goes with this, and it is due try and get it done before next class so you can ask questions and then get it done that